Okay, we are working on section 3.3, which is increasing and decreasing functions, and starting the first derivative test. So the first two definitions of increasing and decreasing, we already know what it's going to be, just with a little bit different context. So we are increasing on an interval if we know that if x1 is less than x2, that implies that f of x1 is less than f of x2, which means that obviously f of x2 is a higher point. So the opposite for decreasing, if x1 is a smaller x value than a bigger x value than x2, then f of x1 is bigger than f of x2 if we're decreasing. So if we're testing about the derivatives, this is going to be all about derivatives, obviously. We have a function f that is continuous in the closed interval from a to b and differentiable on the open, so it's the same as a lot of things we've been talking about recently. If the derivative is greater than 0, so it's positive, then our function is increasing. Okay, that makes sense, since a positive derivative means that the slope is positive. Then the opposite goes for if it's a negative slope, that's a negative derivative, then we are decreasing. And if f prime is x is equal to 0, then it's constant. Okay, so find the open intervals for which this function is increasing or decreasing or constant. We need to find the critical numbers. So we need to find the derivative. It's 3x squared minus 3x. We have to set that equal to 0. 0 and 1 are our critical values. So what we need to do then is make intervals, because all the increasing, decreasing, it's all about intervals. So we're kind of going to make a table. Interval. We're going to test a number. We want to know what the sign of the derivative is, because that was what we just saw up above, was if the derivative is positive, it's increasing. If it's negative, it's decreasing. And we're going to make some sort of conclusion based on what we found so far. So our interval, unless it's told otherwise, is always going to start at negative infinity and go up to our first critical value, which in this case is 0. And it's going to go between the critical values. And then it's going to go up to infinity unless told otherwise. Okay, and then you're always going to pick a test point that's in our interval. So our first interval is from negative infinity to 0, so I'm going to test negative 1, 1/2, and 2. And you put those into our derivative, which is 3x squared minus 3x. If you put negative 1 into there, we get 6, which is greater than 0. This is negative 3/4, which is less than 0. And 6, which is greater than 0. I will often, instead of actually finding the specific number and writing that down, I will say that this is positive, negative, and positive. It's just going to be easier to figure out from there. So if it's a plus sign, the conclusion is that we're increasing. A minus sign, that tells us that we're decreasing. And then we're increasing on the last one as well. And that's it. You would need to rewrite those intervals, so increasing from negative infinity to 0 and 1 to infinity, and decreasing from 0 to 1. Okay, guidelines for finding intervals. Let f be a continuous function. To find the open intervals for where we're increasing or decreasing, this is exactly what we just did. Locate the critical values. Use these numbers to find intervals. Determine the sign of the derivative in at least one test value in each interval, and then use that to determine whether we're increasing or decreasing. That's exactly what we just did, and then this is just guidelines to go back to if you forget. First derivative test. If we have a critical point C that is continuous on our function in our open interval I, which contains C, if f is differentiable in the interval except possibly at C, then f of C can be classified as any of these three things. If f prime of x changes from negative to positive at C, then it has a relative min. If it changes from positive to negative, then it has a relative max. And if it's positive on both sides or negative on both sides of our point, then it's neither a minimum or a maximum. So I drew some pictures to help you figure out what those three things mean. So the first one, here we all have a point C on each one of these little pictures. The first one, we start having a negative slope, and then it changes to positive at point C, which, as you can tell, goes from negative to positive, that would be a minimum, I'm sorry, relative minimum. Ahead of myself. Second one is a max, because we have a positive slope, then changes to a negative slope, that is a relative maximum. And then the bottom two, so the first one on the left is increasing and then still increasing after C, and the bottom right one is decreasing and then still decreasing. Neither one of those are mins or maxes. Either a min or max. You know, we're going to use that first derivative test again, so we did a couple examples ago. We're going to do the exact same thing to find the relative extrema this time instead of just the increasing, decreasing intervals. So the first thing we need to do is find the derivative. 1/2 minus cosine x. That looks silly. Cosine x. There we go. We want to know when that's equal to 0 to find our critical values. That happens at pi over 3 and 5 pi over 3. And you can use the unit circle in our interval from 0 to 2 pi to find those 2 points. Then we make our little table. First we have our intervals from 0 to pi over 3. Since it tells us what our interval is, we know we're not going to start at negative infinity like last time. Pi over 3 to 5 pi over 3. And 5 pi over 3 to 2 pi. Pick a test number. We want to know what our derivative sign is. And then we're going to make our conclusion. Test value here, we'll do some nice trig numbers, pi over 4, pi, and 7 pi over 4. It's negative in the first box, positive in the second, and negative in the third. So we are decreasing, then increasing, then decreasing again. I often draw a mental picture when I'm trying to figure out whether it's a min or a max based on the decreasing, increasing. So decreasing, then increasing, well, that looks like it's going to be a minimum. And if we're increasing, then decreasing, that's a max. So minimum at pi over 3, and then you'll need to plug that number back in. We can just stick with the x value for now. Minimum at pi over 3, and a maximum at 5 pi over 3. Those are both absolute within our interval. Okay, find the relative extrema of the next function. Take the derivative. Rewrite it a little bit. Okay, so critical values are when f prime of x is equal to 0 and when it doesn't exist. So this happens when x is 0 and it doesn't exist at x is plus or minus 2. So our critical values are -2, 0, and 2. So we're going to have a couple extra intervals because we have 3 critical points. Starting at negative infinity, going to -2, -2 to 0, 0 to 2, and from 2 to infinity. Always pick a test number, sign of the derivative, and then the conclusion on the bottom. I try to pick the easiest numbers possible and then plug those in. First we're negative, positive, negative, positive. Now I'm just skipping plugging those in because that's simple algebra and I want to get through the calculus part of it. Decreasing, increasing, decreasing, increasing. So using our little, we could draw a little mental picture if we need to. We know we have a minimum at -2, 0, and 2, 0. and a relative max at 0, and the y value is a cubed root of 16. Find the relative extrema. One more. We are actually going to skip the bottom one, so this is our last one. I would probably rewrite this as x squared plus x to the negative second, because then our derivative is a lot easier. 2x minus 2 over x cubed. And find our critical points. We're equal to 0 at plus or minus 1. Zero is not in the domain, so our derivative doesn't exist at 0, so we also have to test that one. Okay, so our intervals, starting from negative infinity to negative 1, negative 1 to 0, 0 to 1, and 1 to infinity. Test sign of our derivative and our conclusion. Negative 2, negative 1/2, positive 1/2, and 2 are going to be the easiest values to plug in. We're going to have negative, positive, negative, positive. So we are decreasing, increasing, decreasing, increasing. So we have minimums at negative 1, 2 and at 1, 2. But there's actually no max at 0, since 0 isn't in the domain. So just be really careful about that. Don't just assume because it goes from increasing to decreasing that it's going to be a max. It's actually not it's not going to be in your domain of the original, so it's not going to work. So we're going to skip the last one, and that is all we needed to do for section 3.